Test, test, test. Okay. Let's see. I think this one. Hey, I'm just starting another session. At which notebook or at what point did we left?
Hey, nice to start a new session. We last visited the general idea of embeddings. Tokens are turned into vectors, then. Hey, great question. I don't actually have a persistent memory of where we left off unless we explicitly track it here, because I can't see your notebook directly in a way
Yeah,
that
no, okay,
sticks
then let's
between
go over
sessions.
the notebooks again. Which notebooks have we done or what's next? 00B, I think we still need to do, yeah. So let me run it again and you take a screenshot.
Okay, let's start by seeing what you've opened now. Let me take a quick look. The window listing tool is still running from here, so I can't see any new options yet. If you'd like, you can tell me the notebook name or copy a
Yeah, please
screenshot
have
or
a
the
look
text,
at that.
and I'll help you pick up from there. For now, just run it and.
Okay, also I'm just reading over this and the learning outcomes, the first point, with as a larger vector space. So we have different layers that are the sequential
Okay,
transformations,
let me take a
right?
quick look at
And
what's
the
on your
length
screen.
of that layer is basic or dependent on the size of the vector space, so the dimensions, I guess.
You're right, that's the idea. A transformer operates in a high-dimensional vector space. Each layer applies a linear transformation, like a matrix multiplication, to the vectors it receives. The length, or how many dimensions live in that space, is the embed size, or hidden dimension size. So the model's outputs stay within that dimension count, and each layer transforms the representation, potentially
And
mixing and
since
refining
the
across the
final
input.
output head
That's why the
is
dimension count
basically
matters.
like the probability or like the logic for each item in the vocabulary, we can say that all layers have this length, or is this like the minimal length or width of a layer?
Yes, exactly. The final output is a vector of probabilities or logits, one value per token in the vocabulary. And yes, you can think of each layer as having a fixed width. That width is the number of dimensions, like hidden size, used throughout the model. The final layer has that same width, and then the head, often a linear layer, maps it to a vector of vocabulary size so it can score each token.
Okay, then let's look at the next notebook, the one residual stream, please.
All right, let me take a quick look at that notebook and we'll walk through it together.
Okay, my connection is very bad again. Oh man, why is the internet so bad?
Oh no, sounds like things got glitchy there. No worries. Just say your question again, even if it's the same. I'm still happy to help with the residual stream idea. If you'd like, I can also gently summarize the key point of the section before we dive back in.